Welcome to part 3 of 3 of the Communication Networks presentation of Retrofit Strategies. Maximize your infrastructure while migrating from analog to IP technology. In this part, we're going to be talking about the third option in the migration strategies, and that is what we call the retrofit option, where you're utilizing existing cabling infrastructure to deploy new IP cameras and sensors, as well as a new head end. So as we take a look at the key design considerations for the retrofit example, let's take a look at the cabling infrastructure that we have in place in an analog scenario. Typically you'd see about 85% across the marketplace of coaxial cable, and that can be RG59, RG6, and even some other types of cabling. Then you saw also a lot of category cabling, Cat5, Cat6, Cat2, Cat3, things like that. In addition, you saw fiber optic cabling. So now you can choose whether you want to take advantage of that existing infrastructure and not have to go through the hassle of the labor and the cost of removing that cabling. Next, take a look at the distances you might encounter on those cables. So coaxial and UTP cabling vary greatly. It could be 10 or 20 feet long, or it could be as much as 1,000 feet of RG59 or something like that. So you need to take that into account as you migrate to IP. If you're going to use Cat5, Cat6 cabling, some of that is within the 100-meter distance limitation, some of it is not. So if you can take advantage of that cable, leaving it in place, there's a significant advantage to that. Then when you take a look at the power requirements, are your new devices PoE, or do they also have additional powering capabilities such as 12 volts DC or 24 volts AC? And if you're able to utilize existing power infrastructure, that may be an advantage. But also, with new retrofit scenarios, you can remove all external power requirements and power it all with a pass-through PoE. And that might be a significant advantage in a number of ways that we'll get to. Next, when we talk about installation scenarios, if you had, say, one camera over a coaxial cable, you don't necessarily need to replace that with one IP camera over that same coaxial cable. There are ways to get additional cameras over that same existing cabling. So that begs the question, is there the possibility to do a complete review of the original design parameters to see if you're going to exchange those existing 32 cameras for new 32 IP cameras? Or is there a way to either add or remove the number of cameras there and then satisfy those customer requirements in a different way? Also, you want to take into account access to the site. Do you have full access to be able to remove the cabling and remove the cameras and replace them with new cameras? Vertical marketplaces like hospitals, prisons, corporate offices, things like that, sometimes they do not want you to be in their facility throughout the day with two workers going down a hallway with ladder popping ceiling tiles. Sometimes access disruption or service disruption to that customer is a significant hindrance. Not removing the cable can remove that issue altogether. Also with topologies. Now when we take a look at removing the cabling and putting in a full network like we did in the previous example, that gives you access to a lot of different topologies. But when you're keeping the existing cabling, now you have a very simple home run topology because that cable is already in place in a home run fashion. So that can be a significant ease in terms of designing the network and designing the bandwidth constraints and things like that. So again, keeping that cabling and using it in a point-to-point topology may again be an advantage. Let's look at a specific example. In this case, we have an existing analog camera over 500 feet of coaxial cable coming back to a typical DVR. Now when your customer asks you that they want to investigate or replace that with an IP camera, what are your options for installing that? The first option is to use Category 5E, Category 6 type cabling. And that can certainly perform the task, but it can't go 500 feet. So you'd have to have some type of active Ethernet device somewhere in between there. Sometimes that can be easy with certain applications and scenarios, but most of the time it adds a layer of complexity and cost to the system. Secondly, you can replace that coaxial cable with fiber optics. That can certainly handle the distance of 500 feet. However, you still went through the expense of removing and replacing the cable, and at the remote location you still need to power that media converter and that camera. So you still need local power. So here's a new scenario in the retrofit world. We can replace the head end with a network PoE switch. We can come out to a media converter that converts the Category 5 cabling over to coaxial cable that was already existing, go the full length of the 500 feet, add another media converter, and add the camera. All three of those remote devices can be powered with that internal PoE switch. This gives you the ability to remove all external power requirements and cover that distance over the existing cabling. So that satisfies a whole bunch of positives for this installation, meaning you've used the existing cabling, you've removed external power, so really all you've had to do in the field is replace the camera, add the media converter, and connect it to existing cabling. The rest of the work happens at the head end. So you've removed the access to the site problems, you've performed the function very, very quickly, and you've removed some of that risk of having to pull out the cable and running into problems doing so. So there's some distinct advantages here that we'll look at and take a closer look at in the following slides. So here are the key benefits of moving forward with the retrofit scenario of migrating from analog to IP. Number one, if you can greatly reduce the cost of the system, this gives you the opportunity to come back to the end user and invest their dollars in technology instead of the labor and the cabling cost of removing all of and swapping out all that cabling. That can be a significant benefit to you, or if your cost is just lower, it allows your bid to look significantly different than another competitor's. Secondly, it can remove a lot of that unknown scenario when removing cabling. If you budgeted X number of hours to remove all the cabling for those existing cameras and it takes you significantly longer, you could potentially have to eat that cost. So it removes a lot of that unknown cost of the install. Third, it offers a dedicated link. Because you have that existing cabling in a point-to-point scenario from the remote device back to the head end, you don't have to calculate bandwidth, and you don't have to manage a remote device. So it becomes a much easier task to implement and install. Limited service interruption we talked about. Being able to just go to the camera location, swap out the camera, add the media converter, and then get out of that location and not have to remove the cabling might have a significant advantage to you while working with that customer. Centralizing your UPS. If you remove all external power requirements by using this pass-through PoE function, you can centralize your UPS, and then you have a much more higher probability of keeping the system up because you only have one UPS. You don't need to worry about remote locations and their power and their UPS supply. And in general, you're going to be reducing the overall power consumption of the system, and that may give you an advantage in terms of working with a green initiative that your customer may have. It might get your project funded, or it might get it increased in priority. Let's take a look at some of the ComNet tools that you can use to implement a retrofit network. Our product line called CopperLine gives you a lot of functionality that most of the other competitors can't touch. So I mentioned the pass-through PoE function. Well, the reality is our CopperLine units can be powered one of three different ways. They can be powered 12 volts DC with the included wall wart power supply. They can be powered off a 24 volt AC power supply, or the pass-through PoE. So in this graphic example here, we're powering each device individually with local power. The advantage here is that you're getting greater distances over that Coax or UTP. I think the most attractive option here, though, is to take advantage of the pass-through PoE. So in this case, we have a PoE switch at the head end, and it's powering both CopperLine media converters and the Rode camera over that existing Coax or UTP. This gives you advantages in a number of ways. It's an easier implementation, it removes those external power requirements, and it allows you to centralize that UPS. Another distinct advantage is the ability to rack mount the head end solution. A lot of other solutions in the marketplace today call themselves rack mounted. The reality is it's 4 or 6 or 8 mini units screwed down onto a shelf with a fake faceplate in front of it. So in this case we have 8 and 16 channel rack mounted units all in a 1RU chassis. This gives you not only very condensed footprint at the head end, it gives you a significant cost per channel savings on this. So you can have up to 16 channel receivers and up to 16 channel mini units out in the field, all coming back to that centralized unit. So what are the full capabilities for distance and power for these units? Well, the CopperLine units come in two different versions. They come in a coaxial version and a UTP version. Our ratings are based on RG59, and you can see the way the units work is that they maintain a 100 megabit full duplex connection until they reach a certain distance, and then they come down to a 10 base T full duplex solution. So really the worst case scenario here is we talk about 1,500 feet over RG59 is going to give you 100 megabits full duplex and give you about 13 watts of power for that camera. In addition, if you take a look at additional distances, we can cover out to as far as 5,000 feet over RG59. You're going to get 10 base T connection, and you're going to have about 4 watts available for that camera. Now, if you're using something other than RG59, for instance, RG6, you're going to get slightly better results. But in addition, if you go the other end of the spectrum, if you're using silver braided cable TV, or if you're using copper coated silver core coax, it'll still work on those, but you just need to test those distances to make sure it satisfies your requirements. Now when it comes to the UTP version of the CopperLine product line, there's a couple of very key points you need to keep in mind while taking a look at these. Because there's not as much copper in a category cabling as there is in coax, you have to watch your distances. So 500 feet will give you 100 megabits full duplex, and it'll give you full PoE. And also bear in mind that if you're going to use that pass-through PoE, you have to use a cable with 4 pair. If you're just using data, you can use a single pair. It can be Cat 2, Cat 3, Cat 5, Cat 6, whatever you want, but you're only going to be able to pass data. However, you do get greater distances based on those. Then also, as you take a look down below, you can see the range of products. We have the remote mini units. We have a 4-channel switch that can be connected via coax or twisted pair. Here we have the 4- and 8-channel rack-mounted units to get nice rack density and bring your cost per channel down. And then here we have a small 4-channel shelf-mounted unit. Let's take a close look at the CopperLine units. You can see that they cover long distance over their respective cabling. They allow the pass-through PoE out to the camera. They do handle jumbo packets, for they're ideal for some of those megapixel cameras that are producing jumbo Ethernet packets that some devices have trouble handling. They're simple to install. There's a couple of dip switches to set. There's no IP address or anything like that. They're fully hardened, minus 40 degrees up to 75. They carry a lifetime warranty. And again, these can be powered 3 different ways: 12 volts DC, 24 volts AC, or the pass-through PoE. This gives you flexibility during the design and implementation stage, as well as down the road if you switch out any of those new IP cameras for something else and the power scheme changes. You maintain that unit, and you're able to power it differently. These are designed and made in the USA. So if we take a look at the overall summary of the 3 options we've looked at, the retrofit example gives you almost all of the same benefits to migrating to IP, but very few of the same cons. So lower cost, easier installation, you can use megapixel and HD cameras so you improve your image quality, and you can actually extend the distance for power and Ethernet longer than you can in our standard network example without using fiber optics. The really largest drawback is that you don't get the network redundancy that you would with a full network solution. So by my money, retrofit packs a lot of punch with low risk and lower cost. Well, I want to thank you for spending the time with ComNet for the Retrofit Strategies presentation. Bear in mind this is the shortened, condensed version. If you're looking for more in-depth training, please feel free to contact us. Also, please subscribe to our YouTube page to get additional videos, and always call us or visit our website for additional product and sales information. Thank you.